Over to you, Soumya.
Hello, thank you, Rupa. Hello, everyone. Thank you for taking time to join us today. So I just want to, my background, welcoming all of you into December and welcoming all of you into our presentation today. So we are really thrilled that all of you could join today because we have a lot of exciting learnings and very useful insights waiting for you. And before I jump in, let me introduce myself. My name is Soumya Sri Vinod. I am one of the co-directors of Women in Big Data Bay Area chapter. I run the chapter along with Erica, who is my amazing co-director. And we have wonderful core members who just work so hard to make all of this happen for us. And just to give you a preview into what we are looking at covering today, we will first take a quick look at what Women in Big Data does and how we are involved in the community. And then we'll dive straight into the presentation, followed by some question and answer sessions. That said, here is a little bit about what we do, what Women in Big Data does. So our goal is to build the workforce of the future. So as an organization, we really strive to foster women's careers in the data and machine learning field and empower them as leaders in the data field. So just besides developing the soft skills, technical skills, we do workshops, we run mentoring programs. And this year, we have also started our very popular hackathon. So if you are interested in those, do keep an eye out. Towards the end of the presentation, Rupa will share with us how you can be in touch with us. And there are different venues for you to keep an eye out for any of these programs that I'm talking about, like the workshops, mentoring program, hackathon, etc. So let's take a quick look at our journey. So we started in the Bay Area in 2015 with just 15 members. So our chapter quickly grew around the world. So it is clear that the initiative was good. And our leaders used this as a platform to share their expertise. And, it was well received, as you can see. And just in 2020, which was just 3 years ago, we officially received our nonprofit status, which was just a feather in the cap for all the efforts the leaders were putting in till then. And looking at the global reach, we have over 20,000 members and about 50 global chapters on 6 continents. So every day we are continuing to grow. So how does our membership profile look like? Our members have a wide range of profiles. We have data scientists, core ML engineers, business managers, software engineers, people leaders from various fields, all of them collectively working towards making this organization a success. And recently we surveyed our members and found that the networking, learning from the peers, and access to trainings were the top 3 aspects that they liked about what Women in Big Data was providing for them. So there was a lot of interest in attending technical sessions as well, and hence this initiative of bringing in a few technical sessions our way. In a quick look at our roadmap. So what does our roadmap look like? So throughout the year, like I mentioned, we conduct workshops, trainings, and our mentorship program gets rave reviews from our participants. And this year, like I said, we also introduced our hackathon program. And this hackathon program will be run by highly skilled subject matter experts. So anyone interested in this can get involved. It's an amazing opportunity if you're interested in doing competitions in that space. And in 2024, we are looking at introducing a few certification programs. And in 2025, we plan to conduct a couple of conferences, which will be a perfect blend of knowledge sharing and celebration of all of us. With that, it will be my honor and pleasure to introduce our speaker of the day. So Dr. Sonal Khosla. She holds a PhD in computer science with a specialization in natural language processing from Symbiosis International University. She possesses extensive experience in developing data-intensive applications, leveraging NLP, data science, and data analytics. So Sonal is currently based in Germany, and she is actually staying up late just to talk to us today. So special thanks for that, Sonal. And she brings with her over 12 years of expertise across research, academia, and industry experience. So she currently works as a researcher in Odaya Gen AI, which seeks to harness the potential of AI in the development of Gen AI and LLM-based technologies and solutions. So she actively engages in mentoring and training individuals in the data science and data analytics field. And this talk is Dr. Sonal's way of giving back to the data science and data analytics community, and just to help individuals out to reach their potential. So welcome, Sonal. We are very excited to listen and learn from you, and eagerly waiting to hear what you have for us today. And that said, I will hand over the screen to you.
Thank you, Soumya. Thank you so much for your wonderful, kind words. So I'll just start sharing my screen. I hope my screen is visible to all. Yeah, okay.
Yes, it is.
So first of all, thank you, Soumya and Rupa and Women in Big Data for giving me this opportunity to actually speak over here and share my knowledge. And I also thank all the audience who have taken time to actually come and listen to me. So to start with, I will just give you an overview of what is NLP and different terms, technologies that are used in NLP, how that the process of natural language processing look like. And we'll talk a little more about then generative AI and language models, because that's now where the future of NLP lies in. So this whole talk is focused on NLP and generative AI. I will also talk about what are the career prospects in this field, and what kind of courses can help you to achieve your goals. So first of all, looking at what does NLP look like. Natural language processing, as the term says, is, we are interpreting languages, the natural languages, as in the way the languages we speak and talk, how it can be processed in an automatic way so that, we can interact with the computers in a way that, humans interact amongst each other. So we are using some computer science over here, applying some computer science technologies over here, along with the linguistic knowledge a particular language holds. And therefore, it is a combination of both, natural linguistics and computer science combined together, which actually we define as natural language processing. This helps us, or this, allows us to understand, interpret, and manipulate human languages in a way we humans, interact with each other. We all know what is computer science, but what is linguistics? Basically, every language has a certain set of rules and guidelines based on which the basis or the foundation of the language is based upon. So it's a kind of a rule-based modeling. Like every language, generally when we talk about languages, some languages has a subject, object, word, or verb order. Some languages has a subject, verb, object. And similarly, they have a kind of rules, and these rules are actually defined by computational linguistics. So NLP is basically combines the fields of linguistics and computer science to, decipher the language structure and define the guidelines, how this can be broken down, or how this can be, interpreted and used upon. When we use natural language processing, it allows us to define a lot of tasks. It allows us to do a lot of tasks with the help of computers, and we can manipulate unstructured data as in, a text that is written like maybe just a paragraph of English that is unstructured. It does not have a predefined structure. So and also on the basis of what is the context of the conversation, we can actually interpret it. Why do we need NLP? We have nowadays everybody is talking about generative AI. We are talking about ChatGPT. Now, what has ChatGPT enabled us to do is basically we can ask the ChatGPT to actually, it can talk in our language. So if I ask a question to ChatGPT, it's quite enabled enough to actually reply in a language which is directly understandable by humans. So basically it is allowing you to have human computer dialogue system, like we have seen in chatbots. We have seen how the machines can interpret the languages. They can do some sort of analysis on the languages. It can generate language for us. So when we ask a question, the ChatGPT or these language models, they are efficient enough to answer in our language. And it is now earlier it was possible only in English languages because English was dominant, but now it is possible in other local languages as well. Then it provides us some sort of an understanding of the natural languages. It there are various applications where the natural languages can be applied. We have seen it can be applied in chatbots, building chatbots, voice assistants. We on a day-to-day basis we have seen Alexa, the usage of Alexa. Then sentiment analysis. We'll talk about maybe what is sentiment analysis in a while. Then language translation. We have translators which can actually translate language from one language to another. Or text summarization, which means that you provide a piece of text and it can actually give you a summary. Say it's efficient enough to if you provide a document to it, it is efficient enough to actually provide you a summary, a gist of the document. What is it talking about? So it has various benefits, like how it has affected it has actually changed how the industry works nowadays. Like for example, we have the usage of chatbots for customer assistance, and there is no need of humans sitting and replying to queries being generated by different customers. We have chatbots who are can interpret and work on basic questions and answer them. They can do sentiment analysis, as in say suppose there is a product on a website and one wants to see what kind of review the a customer has posted upon it. And so therefore it actually analyzes the sentiment, analyzes whether it is a positive or a negative review. It can provide advanced analytic insights that were earlier it was possible, but it was possible through a lot of human efforts. But now through natural language understanding, it is possible to actually do advanced analytics onto it. Then it enables personal assistants like voice assistants and like Alexa to interpret spoken words. So you can actually convert the speech to text, text to speech conversion is also possible. Then it can, as we discussed, it is the ability to automatically create a summary of large and complex textual content. It is also very efficient enough to do documentation. Now the ChatGPT is good enough to actually write code for you as well. So there are a lot of benefits of using natural language processing. These are the different applications where it can be applied upon. I think we have a kind of, I've just shown you, but I'll just take you through some of the terms which we have not discussed over here, like named entity recognition. Named entity recognition, say suppose I have a piece of text and I would like to find out, who is the person who is being spoken about in that piece of text. So we can the NLP process is efficient enough that it can identify the names from that particular piece of text. It can identify organizations or different locations. Then it is also, good enough for doing some sort of part of speech tagging. Part of speech tagging, as in we have a text, and, as we know in normal language, when you are studying, English language, there is a certain grammatical category associated with each word. So the computer, the NLP application can actually categorize these words into the grammatical category, which actually helps in further interpreting the meaning of a text, or how it can be used for further analysis or for building models onto it. um, Also, for clustering of text, like say suppose we have a group of reviews, a batch of reviews with us, we can actually, through clustering, these reviews can be grouped together, which, reviews which sound similar, or reviews which sound talk about a certain problem or related problem, so they all can be grouped together into a single cluster. Reviews which is talking about another set of problem can be grouped together into another cluster, and so there are different applications of it. Now, before actually moving into the LLM models or generative AI, I would like to, take you to the basic process of natural language processing. And this process is also followed in further, auto-generative AI as well. So we'll talk about how does, the entire NLP pipeline would look like, and how the language is interpreted by the computers, how the basic processing of it is done. So basically over here, the language is or a piece of text or a voice is basically converted into its small parts, and these parts, depending on what is the type of work that needs to be done upon that language, it is broken down. So we have a piece of text or a paragraph, which is broken down into small chunks. These chunks could be some sentences, or it could be some related phrases, and then they are converted into a machine interpretable form, that is into vectors, that is into a quantifiable manner, into quantification of it is done. And then how these words are related to each other, then some sort of modeling is done onto them. There are different models available, and these models actually see that how these words are related to each other, and what if it is a natural language generation task, then how the association of these words can actually generate a language. So basically, it's divided into three tasks. One is to break down into constituent parts. Then it, how to interpret how this data is related to one another. And then, how these connections actually make sense. So this is how a basic pipeline of NLP model creation. If one wants to build an NLP application, then this is how it would look like. There is some sort of pre-processing or normalization that needs to be done on the text. And the text over here is generally in the form of raw text, and this raw text is called as unstructured data. So when we are actually talking about building NLP pipelines, we are actually talking about some sort of unsupervised learning. If any of if you are aware of what is machine learning, what is supervised learning, unsupervised learning. So machine learning is of two types. When you're doing some sort of the data that is provided into the NLP pipeline, if it is labeled, then we say that it is a supervised learning model. However, if it is not labeled, then it is an unsupervised learning model. So what do we try to achieve over here is that if we want to build an NLP pipeline, the data that is given to us is generally raw text. It is not labeled. We can have labeled data for building our models. And this label, like say, suppose if I want to create a sentiment analysis system, so I would need, some sort of a label data to build the model. However, when we are going to generate the model, when we're going to generate the output, it would be on some unlabeled data set. So it could be, it could be a type of an unsupervised learning, or it could be a supervised learning, depending on what kind of task that needs to be done. So over here, this pipeline actually shows you that this is a classification model. So classification is done. So we need, this is going to classify the text into different classes. So the first step over here is to actually, do some pre-processing and normalization. I just wanted to give you an overview of, certain terminologies that are used over here in natural language processing. Just to give an overview, how does it work? So how does the machine interprets the text? So these are the steps that are, done in pre-processing. Then once we have done some pre-processing and the data is actually converted into a quantifiable manner, it is converted into vectors, it's like a normalized text. Then we see that, how these models or how these, words or the pre-processed data is related to each other, which is called as, feature extraction. And once we have, some sort of, feature learning has been done from the data, we build the model onto it. I will, again come back to this diagram. So I'll just take you through. So first of all, as the first task is to actually convert or segment the text into small constituent parts or sentences. So you say, suppose you have, I have a sentence over here which says a dog is barking and the caretaker is scared of him. So, this can be interpreted as two different sentences, like a dog is barking, the caretaker is scared of him, which they are related to each other, but they can be, treated as two different constituent, two different subparts, segments, and then they can be, further taken into consideration for, analysis. So over here, what basic pre-processing was done, yet, any kind of punctuations, any kind of, conjunctions or, words that only add used for, the grammatical completion for the sake of grammatical, completion and do not make more sense over here or may not add to the context of the text is can be removed. And we have two sentences over here. A dog is barking, the caretaker is scared of him. Then the next task is to actually break this sentence into individual words or tokens. Okay, now we have over here a dog is barking. Each word over here is actually a token, and token is a word that is used whenever an NLP processing is done onto it. Then because before we find associations between these words, how they are related to each other, what is the context, in which context it is being spoken upon, and what kind of association it has. There are certain words which are only used for the sake of grammatical completeness and may not add enough to the meaning or may not add enough to the what is the association or what is the basically such kind of words like these are generally called as stop words, and they are articles and pronouns. They actually are used has a higher frequency in a text, and when we further analyze this text, because of its frequency, the high frequency, it actually might give wrong interpretations or wrong analysis. So it is always, advisable to remove these stop words because it does not add to the meaning of the text. So the next is to, actually remove these stop words. Every language has its own list of stop words. So, if you are doing, if you, go through this NLTK toolkit, which was, the one of the first toolkits that was actually used for natural language processing. So the NLTK toolkit had a stop word list for each language, and then it can be used. So if you're doing some analysis on English, then you use the stop word list from English. If you're using it for Chinese, then they have, a stop word list for their language. So that can be used to, identify which words needs to be removed. Then every word, they might have, different forms in the sentence, in a text. So it is, and, if it is used in different forms, then again, we want to interpret the word change over here. And if, we see that, it is being used in different forms, and then in that case, it leads to different frequency in the text. And we are not able to, find out or, interpret it enough. So it is the next step that is advisable is to do lemmatization, that is, convert the word into its root form. However, in most cases, stemming is enough to actually make analysis onto it, or, do some feature extraction onto it. So stemming and lemmatization, depending on what is the type of application, is, finding the lemmatized form may, may not be good for all languages. Some low resource languages, it's really, when they have a lot of complexity in their verb forms, then it is difficult to do lemmatization on them. So in that case, stemming is also good enough to actually cut off the, the stem part, and you just use the, base form of the word for further analysis. Then again, very important step that is done is part of speech tagging, because through this part of its speech tagging, the context and, how the words are related to each other, and what does it mean. Like, say, suppose we are talking about a product over here, and the product name of the product is a noun, is always a noun. So such kind of interpretations can be done with the help of the, part of speech tagging, wherein each word is given a grammatical category. Now, every language has their own set of, grammatical categories. Some of the grammatical category is, is common across all languages. However, with different language complexities, they might have, other, grammatical categories, subcategories for these base grammatical categories. And the next step is to identify the part of speech of each word. Once we have the part of speech, this is also further used for, identifying the named entities. So, if we have a sentence over here, we want to find out what is the organization, who is the person being spoken about, where is the person located, and certain monetary value associated. So such kind of task where we are finding out, these named entities, it is called as named entity recognition. Now, once we have, done some basic pre-processing, and we have tokenized data with us, which it is identified with a part of speech grammatical category. If we want, we can have, some named entities out of it. All of this actually can be used in combination for further analysis. Again, depending on what is the kind of task that needs to be done, what kind of application, NLP application we want to build. There are different ways how which, the feature extraction can be done. However, I'm just going to speak about a few of them over here. So one of the methods is the bag of words. So once we have, a tokenized date, set, a struct text with us, it is directly converted into a bag of words. This bag of words is, what we obtain after lemmatization, after tokenization, and also after the stop word removal, which actually shows you that which are the prominent words, because this bag of words contains the frequency also of each word in the piece of text. So like, say, suppose if, we look at this piece of text over here, I love this movie. It's so sweet but with satirical humor. If it is converted into a bag of words over here, we see that, there are certain words which are, again, these are the words that are coming most frequently over here, because these are generally these top words. And then we have, some words which are some highlight of this text, which actually shows that, the movie is sweet, it's satirical, it's adventurous. So it actually gives an overview of, how what are the most prominent words. Now, if we look at, this piece of text over here, and we see that, the stop words are the ones which have the highest frequency, but this is actually not telling us anything about what is the piece of text talks about. Therefore, it is advisable to actually remove these stop words, so that we have some words, over here, which actually makes more sense and, gives more insights into what the piece of text is talking about. So one of the techniques is bag of words, which where you describe the occurrence of words within a document. It actually gives you a vocabulary of the words in the text, and a measure of the presence of those known words. Measure in over here is frequency. Sometimes it's the probability distribution as well. And now this bag of words can be used for finding associations um, between these words. So when we are finding, some associations over here between these words, which we are actually going to build a language model onto it. And there are different ways of building a language model. Then other is that, if you have to build a language model onto it, there are different ways. Like, one of them is building through neural networks, or, building through statistical models also. Then we can use dependency parsing as well. Dependency parsing is kind of, an old term technology that was used. Now, most often it's the neural models that are used for, building the language models. So dependency parsing is used to determine, how all the words in the phrases are related to one another. So basically, it's in terms of the probability distribution, and it's more statistical in nature. Then one of the common method was the term frequency inverse document frequency, which actually says that what is the frequency of words in a particular document. So it's so these are some of the feature extraction methods which actually can be called upon as building a model. So once we define what methodology we want to use, we can actually further build a model onto it. So what we see over here is that, for building an NLP pipeline, the first is that, we need to do some sort of a pre-processing and normalization. Then we can apply, some feature extraction methods onto it. And then finally, training the model to actually, and this model can be used for what kind of application we want to, or what kind of task we want to achieve. These were some of the, basis on which the auto-generative AI was built upon. Now, generative over AI over here is basically, it's a category of artificial intelligence where the objective is to create or generate new content. Now, when we say that, we want to create a new content, it could be images, it could be text, it could be a voice, it can be used for generating new content of different types. And the auto-generative AI is good enough to actually generate new data, which is very realistic. It has, a lot of creativity associated with it. You can ask your ChatGPT to actually write a poem for you, and it is efficient enough to write you a poem. It learns from the data, and it is autonomous, so it works on its own. And once the model is built, it can be, reused. Generative AI has a lot of applications. It can be used for various purposes. It can be used for forecasting, financial forecasting. It can be used for, designing new content, art, composing music, generating new content. Then, it can be used in the virtual world. Then, it's good enough to demand forecasting. It is, efficient enough to do healthcare diagnosis. So these LLM, generative AI models can be used for variety of tasks. However, not all models are, good enough to actually do all kind of tasks. So in some ways, you need to actually kind of customize it to your application or what kind of task you want to achieve with them. So as I told you, when some sort of feature extraction is being done, there, we are actually building a language model. Which is the basis of, large language models on which is actually a part of generative AI. So, we have generative AI, which is, good enough to generate different kinds of applications for you. But now we are only going to talk about how it is, the large language models can be used to generate text. So large language models, the basis of large language models is a language model, which is a probability distribution over a sequence of words. And this probability distribution also has, learned how these, words are related to each other by, training them on text corpora. And, these probabilities are generated by training them onto a raw text or a corpus, and the language model is built. So this is, what it means over here when we say that it is a probability distribution. It is statistical in nature. But, nowadays, neural network models are used for actually, language model is the basis, but neural networks are used on top of it to actually reuse the information generated by these probability distribution, and then, relearn from the outcomes. Now, when we say it is a probability distribution, basically it is a distribution which allows us to, predict what could be the next word. So over here, it is actually, predicting the next word because it is generating content for us. So it is a probability distribution of how, what would be the next word. So when we say that, it is a statistical language model, it actually uses probability distribution to make predictions about the next word. Now, where does this information come from? This information has been fed into the model. The model has actually learned from the training corpus that was provided to it. And then it, has some sort of a probability information which says that, the students open their books, they can open their books, they can open laptops, they can open exams and minds. But the, probability, most likely the probability is that, students open their books. Now, again, it is not only dependent on what is the next word in this case, is not only dependent on the probability, but it is also dependent on what is the context in which it is, spoken upon. So it is not learning from one sentence, it is learning from entire paragraph or the entire piece of text that is provided to it. And based on that, it has generated a probability distribution, which helps the model to predict the next word. Then, the neural networks are also used. They are more efficient and effective. So neural network is basically, multiple layers that are there. So, with one layer, it has some learnings. With this learnings is utilized in the next step. These learnings then, is utilized in the third step. So it's basically a layer of, network. And therefore, it is more efficient and, more effective to make predictions about the language. Now, what is a large language model? Large language model is basically, is a language model consisting of neural network with many parameters. It is trained on huge data sets. and which is generally unlabeled text. Now, this data set is used from variety of sources. It could be, from the internet, it could be from books, web pages, and so on. So it's built on a huge corpus, is trained on a huge corpus, and it has, typically billions of weights or parameters, on which it is being built upon, from which it actually learns. Now, this actually transformation or this revolution actually started when the transformer architecture was introduced, a few years ago. This transformer architecture actually forms the basis of most of the language models that we have nowadays. So, in this around 2017, we had this, Google launched the transformer, and which actually forms the basis of all the other large language models that are there in the market nowadays. Some of them are open source. They are available for, retraining or for use in your applications. You can use them directly in your applications. However, some of them are not open source and they cannot be used. So what does this, this diagram just shows that, every year the model has, size has increased by tenfold. So earlier it was, trained on, some 0.11 billion parameters now, but this number of parameters that are used to actually build the model has grown, tremendously, exponentially over the years. And therefore it has become, more efficient and impactful. I think, yeah. So we know that, there are different applications of large language models. It can be used for content generation, part of speech tagging, which was earlier a part of, NLP processing, can be now directly, you can provide a piece of text to a large language model, and then it can give you a part of speech tagged data to you. It can be used for question answering, text summarization, sentiment analysis, conversational AI, machine translation, and even it can write codes in computer programming languages as well. This is how the LLM application lifecycle look like. So you can actually, because as I mentioned, there are different open source models. You can use these open source models to actually create your own large language model. However, you can build your model from scratch as well, but the only restriction is that you require huge amounts of training data, and because it is trained on billions of parameters, you require computing resources and so on. So we are going to look upon an LLM application where you are not building a model from scratch. However, you are using the existing LLM models to apply it to your application, or how you can actually train your own model based on these open source models available. But so this is how the LLM application life cycle look like. So what we have is we need to first define what is the use case or what kind of task I want the LLM application to do. Then you would actually choose an existing model, most likely, or you pre-train your own. You are not building a model from scratch. This is an assumption in this application. I'll talk about more, what are the constraints of building the model from scratch as well. So you actually, choose an existing model or you pre-train your own. You try to adapt the model as per your use case. Now, there are different ways how you can, adapt the model and see, whether it is working as per your expectations or not. So there's prompt engineering, fine tuning, or actually, you would evaluate it with human feedback, because, we humans are the best in the language understanding. So you try to evaluate, whether the model is meeting your expectations or not. And once you have, a built-in model, you would actually deploy it for your application. So as I just mentioned that, you would never, you can, but you would not do train a model from scratch because it would require huge amounts of data set and computing capacity. Then, how good the model performs depends upon, what is the quality of data, how much, and it will require time. I think, Rupa, I'm just running short of time, but yeah, let me quickly. So,
yes, please go ahead. Yeah, I have not seen any question, but yeah, try to wrap up. Thank you.
So we need to, define the use case, what kind of task we want the model to do. One of the best, simplest way of using an LLM for your own application is prompt engineering, prompt engineering. So, it's like similar to how you use ChatGPT. You provide an input, the model is already there, and it provides you an output. However, in some cases that, the model may not understand your question well. So then in that case, you can provide some additional information to it so that the model, behaves in the way that is expected, or it behaves, it provides you an output as you wish. So in that case, this iterative process of, improving your model is known as prompt engineering. But this prompt engineering has certain limitations over here, is that, when you're using prompt engineering, it's more often is not, understanding certain domain specific data. Say, suppose we have a language model which has been trained on general purpose data. So it's been trained on English, but on generic data. Now you want to, make your model work for some certain financial applications. Now there are certain terminologies there are that, that is there in this domain, which is specific to the domain, and you want, the model to actually understand these financial terminologies. So what would you require is that, you would try to customize this base LLM, and is going to pre-train the model, which is called as, fine tuning. So you're going to provide some domain specific data set to it, and then, the model is going to relearn from the domain specific data set. So we already have a gigantic data set over here. We already have a base language model. However, we are not going to, customize it for our own application and, provide some domain specific data to it, which is called as, fine tuning. And then we have a fine tuned language model. Now, this is, a supervised learning process. So the data that you provide over here is basically a pair of, input and output that is expected from the model. And then the model, learns from it. Say, suppose you want to build a question answer system. So you already have a base LLM. Now you provide a question answer system with regards to financial domain. And then the model is fine tuned. And then you have a fine tuned LLM. This input that you provide to the model over here is basically known as instruction data set. And then you say that, the model is instruction fine tuned. But again, how do you interpret how the model is performing as per your expectations? Because there are certain challenges that are associated with it. And there we have certain metrics that are, can interpret or analyze what the output, whether it, reaches, meets the benchmarks or not. However, most often these benchmarks or metrics are not able to, you know, find out certain, challenges into it. Like, the model might generate some harmful content, or it might generate some toxic tone or voice. So therefore, the model is always evaluated through human feedback. Human intervention is needed over here to see that, the model is behaving as per expectations, and it follows 3 human values. So, these 3 human values are that, the model is helpful enough, the output that is generated is honest, and it's not harmless in any way. So this methodology is called as reinforcement learning through human feedback. So a combination of these three methods, prompt engineering, fine tuning, and RLHF, you get a model built. Now you can use this, model for your own purpose. So I'll just go through it. Sorry. So, we have adapted and aligned the model as per our expectations. We evaluated it, and then we have a final model with this. With this, model can be used for further, deploy it for our own applications. Now, there are certain challenges or limitations of large language models, which is one of them is known as, knowledge cutoffs. If any of you have used ChatGPT at any point of time, if you kind of, ask them any question related to the latest events, you get a generic feedback, a response that, the model was trained until 2020 and is not able to, make comments about the events that has happened after that. So it has a kind of a knowledge cutoff, the open version of, the free version of ChatGPT has a knowledge cutoff until 2020, and it does not have information about the events that had happened, after that. So these are some of the limitations. And then, it is not, again, still good enough to handle complex mathematical calculations and tasks. Then the model is, has a tendency to generate even, information, even if they don't know the answer. So it kind of, makes inferences based on the incomplete information. And even if the model does not have any information or does not have relevant information, still it tends to, answer to your question. Then, languages are dynamic in nature and they evolve, and, the linguistic complexities, they change. So these LLMs needs to be retrained. So they still struggle to, keep up with the linguistic changes. This is most likely happening in case of, low resource languages. But for English, it is quite, working well. So, when these LLMs has certain challenges in terms of, knowledge cutoffs, or if they are not able to retrieve information, relevant information based on the question that is provided to them. Another approach that actually tries to overcome the, challenges in this is the retrieval augmented generation, which means that, if a question is provided to the LLM and if the LLM does not have any information on that, then it can actually go and look for external data sources, fetch information from these external data sources, and then provide a response to the user. So this approach is called as retrieval augmented generation, so which is a framework for building LLM applications that can actually retrieve information from external data sources. So what we have over here is we have more relevant and accurate information. This is how, a complete LLM application architecture would look like. So we have certain infrastructure, we would require some methodology, what could be cloud-based, it could be local. You have some infrastructure, we have some information sources from which the LLM models are going to be built. We have an optimized LLM, and then we have evaluated the output, and this, can be used. On top of that, we can have, an application interface, which is going to interact with the LLM models and provide output to the users. LangChain is one of the retrieval augmented generation methodology, which can be used to actually fetch data from external data sources if the information is not available. There are certain ethical issues in AI. There are more actually, but I'm just covering a few of them over here. So when the LLMs are trained on large data sets, they may contain, they may be biased because, if they have been trained on a data set, if the data is fetched from internet sources and the internet sources contain biased information, maybe related to politics or maybe related to any other topic, then in that case, the outputs generated by the LLM models are also biased. They are considered to be as black boxes, and it's really difficult to understand or to actually make sense from these LLMs that why they are answering in such a way. So they still lack explainability, and there's a lot to be done. Then there is a privacy issue, which is one of the major concerns of LLM models, is that they are trained on vast amounts of data, and this data may contain personal or sensitive information. So these are some of the challenges that needs to be addressed. Then other is that ambiguity, that sometimes the text that is there in the can be ambiguous. Ambiguous can be the word, like for example the word bank. The bank can be used in two different contexts, so it's ambiguous in nature. So it needs to have a context understanding, which is still it's developing. The NLP, there is still a lot to be done in multilinguality. It's good enough for English. However, for low resource languages, it's still developing and it's in the early stages. And then we also saw that, it has some privacy and ethical concerns, and it should adapt to, real world adaptability, because as we say that, languages keep on evolving, and, not always, we are talking in a similar manner. The dialects change, the way the language is interpreted, it's different across locations, even one language. So this is something still some of the challenges in natural language processing. There are future of NLP lies in some of the terms or some of the topics where the future is moving ahead is multimodal NLP, where combining text with other data like images and audio. Then few short learning, which means that it's the model is able to learn with minimal data. Again, we discussed that there's lots to be done in terms of explainability, ethical AI, and expanding NLP to less resource languages. So these are some of the challenges in NLP, and hence the future applications are focused more on these topics. And yeah, so it's still to be applied in different industries. Not all industries have started using NLP as one of their core components for their businesses. So it's still there's a lot of scope to be used in different industries yet. These are some of the career opportunities and roles that are an NLP. You can learn natural language processing and apply it in different areas. So NLP scientists basically are ones who actually do research on the advances and understanding of NLP, and they are basically developing new algorithms and models. However, NLP or machine learning engineers, basically, they are more, towards the applied side of natural language processing, where they actually use these algorithms and models to actually build, deploy, and use it for NLP applications, use it for real world data, and can see the direct impact of it. So it's actually used in businesses directly. Then there are, data scientists focused on NLP, who are, not specifically deploying or optimizing these machine learning models, but however, they are, analyzing and interpreting large volumes of data and building models onto it. Then there's another new role, which is the conversational AI developer, which is, focused on building chatbots and virtual assistants, where they are actually focusing on basically conversational artificial intelligence. And then we have the NLP consultants, which can provide expertise and guidance on implementing solutions. So basically, they are more focused on, understanding what is the business requirement, what does the client want to achieve, and then what kind of strategies or what kind of approaches or what kind of applications they can build to actually optimize their business solution or to find better business solutions for their applications. These are some of the courses and certifications, though these are not the only ones. There's a lot open freely available courses, and but yeah, Coursera or Udemy, they have one of the good natural language processing courses. One of them very good is the deeplearning.ai, which actually contains courses designed by Andrew himself. So yes. Any questions?
Hello there. Thank you so much, Sonal. That was very, very informative. I'm sure everyone has taken, a lot of points away from talk. If there are any questions, please feel free to either type in the chat or, ask. We will be sharing this, the recording of the talk as well as the slideshow. So please let us know if you have any questions right now, or feel free to send us an email. I will put that in our chat, or you can, Sonal, I'm speaking on your behalf. They can reach out to you, and if they have any further questions or seek advice, they can reach out to you.
Yeah, sure. I can provide my email address as well, or you can reach out to me on LinkedIn. So yes.
I guess, Sonam, I just have a couple of slides, so if you could please move to the next slide.
Yeah, sure.
So hello everyone again. If you please again feel free to type your questions in the chat or email. Sonal will be typing her email address, as well as you can reach out to her on LinkedIn. We have provided her LinkedIn profile in the meetup as well as in the slideshow, and we will share that later. As Soumya, our Bay Area chapter co-director, explained, there are multiple ways to be part of Women in Big Data. Everyone is welcome. We are looking for volunteers. You can find us at these different social media handles, like what's listed here. And we are always looking for volunteers. There are multiple programs that are going on. Mentoring hackathon, you can join as an expert, you can join as a mentee, you can join as a participant and or volunteer. So please join us, and it will be a journey of like learning and collaborating together. Could you please move to the next slide? I guess that's all. This is the last slide. So thank you very much. Thank you all for attending and taking time from your lunch or whichever time zone you're joining from. We appreciate. And, if there are no other questions, I guess we will be sharing the recording and the slideshow later in a week's time or so. Till then, good luck. Good luck with your journey in NLP and data science. And feel free to reach out to any of us. Thank you.
Thank you.
Bye-bye. Thanks a lot.